Today we're going to be covering lesson 2.4. Now in 2.4 it says algebraic reasoning. You're really going to start what is a proof. Okay, so I almost want to just change this to say it's the start of proofs. Okay, that's really what we're about to get into. Now I will tell you that the notes for 2.4 through 2.6, so the last three lessons here, these notes do not match your book exactly. I've made a few changes just having gone through it now a couple times, and I just think that this will be so much easier for you. So if you do reference the book, you just might notice some slight differences, some different problems and things like that, okay? All right, so on the top here, I just put the algebraic properties that you've learned in middle school and in algebra class. And so we don't use all of them. So don't think you have to like memorize these exactly, but you are going to see how I'm going to use them below here. Do you notice how it says of equality? I typically don't write this part just because I guess I'm being a little lazy or something like that. But oftentimes if you see a multiple choice test from the book or like on your SAT, you will see this. When you see the word equality, it just means that you're dealing with an equation. So again, don't worry about it. Also, as you're glancing through this list, you probably recognize the majority of them, but you might not recognize transitive. Transitive is kind of a geometric property. I wouldn't worry too much about transitive. I guess what I want you to realize, though, is transitive and substitution are practically the same property. So let me give you like a basic, trying to think like a basic algebra problem here. So if we were to say x plus 2y equals 10, and then you had y equals 5x minus 3. Okay, so I guess I don't basic. This is a system of equations, correct? Okay. If you were going to solve this, many of you would take this piece and you would plug it in right here. So you would remove the y and you would replace it with 5x minus 3. So you would essentially be doing what we call substitution, okay? So that's how substitution works, is you remove something and you replace it of something of equal value, all right? Let me give you kind of a more of a geometric question or problem. Let's say that you have angle ABC equals 50 degrees. And let's say that angle XYZ also equals 50 degrees, correct? Well, in a way, I mean, these are both equal to the same thing, correct? So what they want you to do is they want you to put these together. So you're putting shapes together, though. You're not putting numbers together. So you're putting shapes, and so they should be congruent. In a way, that's the transitive property. But in my mind, I'm sort of still thinking, I'm getting rid of this and I'm going to put this in its place. Okay? So I never use transitive. I only use substitution. But your book likes to use transitive in certain situations. Now, I will tell you that if you are doing a multiple choice, you never see both of these as an option. So kind of just try to think of them as interchangeable. But personally, I just stick with substitution, okay? So, proofs. Basically, what you're doing is a logical order of steps, and you have to give a reason why you're doing what you're doing. So the first two problems are algebraic, just because we've been dealing with algebra for so much in our life that we kind of feel comfortable with it. So you look at this problem and you're like, okay, well, you gave me this problem. So the reason is given. So it's a given. Then you look at this and you say, okay, how am I going to solve this? Now, if we were there in class, I would ask for your opinion. But since I'm sitting here by myself, I would move the 2p to the other side. Now, typically in a proof, we do not do this anymore. Do you see how I do that underneath? We don't typically do that in proofs. In proofs, we kind of consider that part to be understood. So what we would write down is we would add the 2, so that becomes 12. And now you have to say what property or what allowed you to do that. And that's really just the addition property, that you added the same amount to both sides. So I say addition property. Now, technically, I should say of equality, but for most people, they'll let you drop that. Like, nobody really worries about that, okay? Now, we're going to add the 17 over to the other side. Again, I'm not going to write down plus 17. I'm just going to kind of do it in my head. So negative 9 plus 17 would be 8. And once again, I just use the addition property. And if you notice, I am abbreviating a little bit. I don't mind if you abbreviate at all. The only one you have to be careful of is you really have to be careful of subtraction and substitution. Because if you just put SUB, I won't know which one you're talking about. So make sure you either put SUBT or you put SUBS or something like that. Just make sure that you can tell the difference between those. The only other one I always talk to people, you know, division and distributive property, just give me a couple letters, but just be careful on associative because, you know, the first 3 letters, what it abbreviates to. So just maybe give me 4 letters on that one or something like that. You don't see those very often. It's mostly addition, subtraction, multiplication, division, distributive, substitution. The commutative and associative come up once in a blue moon, so it's not very often. All right, now you're going to divide off the 12. And so 8 over 12, let's just go ahead and reduce that to 2/3. But I divided by 12, so that would be the division property. Okay? So notice it's line 1, line 2, line 3. I got a little off here, but that's line 4. Okay? So why don't you pause it here and try number 2? All right, hopefully you said given. And quickly pause it if you haven't already, but you should have tried it. All right, I'm going to go ahead and use the distributive property. So I'm going to distribute the 6. So 6 times 2 and 6 times negative b, and that's the distributive property. So again, see how I abbreviated it a little bit. Now, I'm going to add these 2 together. So I'm going to do negative 10 minus 6. I've seen a few different answers here. In my brain, I added them together. Some people might say subtraction because it's negative 10 minus 6. Some people would even call this combine like terms. So there's about 3 different answers you can give here. Again, they're not going to list all of them as choices if it wasn't a multiple choice answer. So if it was me, I would say the addition property. But again, some of you might say subtraction property. And I've even seen some people say combine like terms. Even though that's not really a true property, I've often seen people write it. So it's up to you how you want to write that one. Okay, now I'm going to move the 12 over. And so if I go 4 minus 12, I get negative 8. So I subtracted. So it's a subtraction property. Now I'm going to divide off the 16. So negative 8 divided by 16 is negative half. So that's the division property. Okay. Now, this is a proof right here. This is a proof. I mean, you just did your first ones, but these are algebraic. And so most of us feel quite a bit more comfortable with algebraic proofs because we've done them for so long. So in starting on 2-5, you're going to move to geometric ones. So, I mean, if you want to look ahead, you have the note packet here or it's online, but you can see we've got kind of a triangle-ish one there. Notice we've got kind of a line, we've got some segments, we've got some triangles. So we're going to move away from algebra ones, but you can kind of still see the style. See how it says statements and then it says reasons. So the idea, the style behind this is going to be the same. It's just changing because we're not in algebra class anymore. Okay? All right. So if you turn your page, we're not quite into the geometric proofs yet, but we're going to try to take baby steps here. And so I listed some of your geometric properties. So things like definition of complementary, definition of midpoint, linear pair, segment addition, all these ones that we've had. Now, reflexive and symmetric are two that most people get confused, and reflexive is used probably more often, if that's the right way to phrase it, more common. I rarely ever see symmetric. So let me show you symmetric first, okay? Let's say, I'm going to give you an algebra problem again, because many of us, our brains just, we comprehend it easier. I'm going to make this really, really basic. Pretty basic, right? You're going to subtract 1, and you're done. But what if your teacher says, no, I do not like the variable on this side. I like it on this side. You need to switch the variable from the right to the left. So you've got given, you've got subtraction, but now what's the property called for moving it from one side to the other side? That's the symmetric property. So kind of think about like when you look in the mirror, you know, when you look in the mirror, if you hold up words in the mirror, it reverses the order of the letters. Okay, so mirrors have that, you know, reverse effect to them. So that is the symmetric property. So I would probably just write down something on your paper like x equals 4, then 4 equals x. It's when you kind of almost like flip them. Okay, so flipping them. I have only seen this a handful of times in my life, and I'm pretty old and I've taken a lot of math classes. Really what it sometimes will boil down to is if you get a super picky teacher and they're like, no, I like the variable. Or sometimes if you have inequalities like this, sometimes people don't like inequalities with the variable on the right because it's harder to graph, so they want you to flip them like this so that it's easier when you go to graph these, so that your symbols like match the direction. So you're not going to encounter this much. I don't know if we even see it in our class at all, but I want to introduce it to you. Now, reflexive. You will see reflexive property in our class. I'm not saying you're going to use it today or tomorrow or whatever, but it comes up in quite a few of our chapters. So you'll get used to this one. Reflexive is when you're equal to yourself. Now, it sounds funny because you're like, well, duh, like 10 is equal to 10. Like, I get that. You don't need that. But what if you're dealing with, let's say, a segment? So let's say you're dealing with segment AB. Isn't that the same as if you're dealing with BA? I mean, isn't that essentially the same segment? So what you're going to have, again, having taught this before, is you're going to get a triangle with another triangle on the other side. This piece right here is shared between the two triangles. So if we were to pull these two triangles apart, this piece is the same in both triangles. So this piece, let's call it AB, is equal to this piece as well. So it's the same piece, but it's in two separate triangles. Maybe this is triangle ABC, and maybe this is triangle ABD. Maybe they're two separate triangles, but they share a common piece. So you're going to see that. You also sometimes see it with angles. So let's call this angle XYZ. If you have angle XYZ, XYZ, couldn't you reverse the letters? Couldn't you have ZYX and it be the same? Okay, so sometimes what you'll also have is you'll have triangles like this that they will overlap each other. And so they'll share an angle and one position. So they'll have like a overlapping piece. Trying to think if I could draw you one real quick, but it's just kind of that concept is that they overlap. Besides that, I think you're pretty familiar with these. We've done these in class and things like that. So how about I'll do a couple and then you can pause it and you can try it on your own. But what they want you to do, kind of the same thing that we did on the front, is how do you go from this step to this step? Okay, so kind of take it like this. You've got your given. Now, this may not necessarily be what you would do first. So you have to kind of almost put yourself in the teacher's point of view, is what did the student do? So what they did here, if you notice, was they moved the 2 over. So they subtracted the 2. And that's how they got the x. So then you should say this is the subtraction property. Okay, so another algebraic one. Now, let's look at a geometric one. So I'm going to cover up. No, if I didn't mention before, what in the world are these 3 little dots? Sorry, again, I've been teaching for so long. Sometimes I think you guys just know stuff and I forget. 3 little dots is sort of like therefore or like conclusion. It just means like you're giving the answer. So it's like, I start with this. What would the next logical step be? So if you notice, now these are angles, but I'm just going to use the numbers so it doesn't get confusing. If 6 equals 7 and 7 equals 8, doesn't it make sense then that we would cancel these out and put this angle here and say these 2 are equal? So notice the next line is 6 to 8. Now, your book, because these are angles, wants to say that this is transitive because they're angles. However, I just say substitution. So I never use transitive. I understand it. It doesn't bother me. I just kind of like substitution because I feel like substitution applies in more situation where transitive is more specific and it's not always usable. So it's just substitution to me is more generic. Okay. How about I'll do one more with you? It says M is the midpoint of a segment. So if I envision this in my head, if M is the midpoint, based on what I know, doesn't that make this side equal to this side? I mean, isn't that what the word means? So notice what they have there. And so the property would be definition of midpoint. I will basically tell you this, whenever you see a vocabulary word, it's pretty much definition of that word, because how do you know what this word is? Like take a little kid, if you have a little brother, sister, or cousin, whatever. If you went up to a 2 or 3 year old and you said midpoint of a segment, they'd look at you like you were crazy. They have no idea what that means. But you do because you've seen it over and over and you heard it and used it in school. So you know the definition, but they do not. Okay, so why don't you pause it here? This is the last page of the notes. So why don't you see if you can come up with what property it might be. Now it could be geometric, so it could be from the list above, or it could be from the other page, which is algebraic. But go ahead and please pause the video here. Okay, hopefully you tried them. I'm going to quick run through them, and then this is the end of the lesson. Notice the switch of the letters. Now, this is reflexive, not symmetric. It's reflexive because it's the same item. In order to be symmetric, you have to have 2 different things. So, hint, hint, look at number 7. Do you see how the 1 is on the left and the 2 is on the right? The only thing that switched is now the 2 goes to the left. So see how the 2 is on the left and the 1 is on the right. So they didn't introduce anything. They just switched that this came first and now it comes second. This is the symmetric property. Again, Very, very rarely ever used, but it does exist, and so I want you to be aware of it. Okay, number 8. Notice, how do you go from here to here? Like, what changed? You got to ask yourself what changed. And what I'm noticing what changed is the order. Now, typically I would say, well, then it's symmetric. Symmetric cannot have addition and subtraction. So this is the commutative property. So the commutative property is the property that tells you that order, when you add and when you multiply, does not matter. Now, I don't know what x and y are. How about let's just say x is 1 and y is 9. I mean, let's just make it easy. That totals 10. Does it matter if I do 1 plus 9, or could I do 9 plus 1? Doesn't matter. The commutative property tells us the order doesn't matter. So that's how I knew what property it was. Okay, if you look at the next one, again, go from here. Now remember, these are conditionals. These are like if-thens. To how did we get here? How did they get rid of this? Okay, now again, your book is going to call this transitive, but I like to call it substitution. So totally your preference. Just make a decision there. Okay, given diagram. How do I know this is true? How do I know that 1 is equal to 3? And if we look up here, we've got vertical angle theorem. Now, some kids will just do this, and I'm totally fine with that. If you just said vertical angles, I would be happy. But if you don't put the T behind it, technically this stands for definition, which doesn't tell me that they're equal. Now, actually, this should have the congruent symbol on it. I might have just forgot to type it because Google Docs does not love our math symbols. Gosh, it's such a pain to insert them, so I might have just forgotten. Just like up here, I just noticed it. Do you see how there's no congruent symbol? Anytime it's a shape, it's supposed to have the congruence like it does here. It's just, man, Google Docs does not love our math symbols. So vertical angles only tells me how they look, that they're formed by straight crossing lines. If you say they're congruent, then you're saying theorem. But again, I'm not going to mark you down for that. As long as you can at least tell me they're vertical angles, I would be super happy. Number 11. 11 is actually from chapter 1. If you notice, it's a segment plus a segment. So it's a segment plus a segment gets you a bigger segment. And so that is segment addition. Now, I would not put SAP. I've never seen that. So I wouldn't abbreviate it that much, but you could probably do segment addition postulate. Now, again, Euclid called some of them postulates and some of them theorems. Now, there is a difference between that, but maybe that's for a whole nother day and not a video here. But it's not a huge deal. So if you don't even put the word postulate, I'd still give it to you. Or if you accidentally put theorem, I would give it to you. The biggest piece is, do you have segment addition? And then over here, notice it says A plus B is equal to 180. How do you know that you can essentially take this word and change it to this word? Like, how do you know that 180 also means supplementary? Because somebody told you the definition of the word supplementary. Again, if you ask a little kid, they are not going to know what the word supplementary means because maybe taught in middle school. I don't remember what level, okay? But that's how you're making the transition. So that concludes the 4th lesson, which is starting to get you into proofs. Now, again, you don't have to memorize this list, but as you noticed when we worked through these problems, I was choosing my answers from this bank up here and then the algebra ones as well. So it's good for you to continually reference them. Maybe every day before you come to class or before class begins, just quick read through them. Or maybe at the end of class, quick read through them, and I think that would be enough.